Okay, this is the P4 paper from January 2024. It's question number 5, which is an integration question. We've got integration by parts up here, recognise, and then the second part is going to be solving a differential equation. Let's have a look at part A then, which is find the integral of x squared cos 2x dx. Now I hope you've done enough practice of these so that when you're looking at this we can see not only is it integration by parts, but this x squared thing is mean that I'm going to need to do the integration by parts twice. Let's go ahead and make a start to it. So I'm going to say u is equal to x squared, and I'm going to say dv by dx is equal to cos 2x. du by dx then just works out to be the differential of x squared multiplied by the power taken off the power, and the integral of cos 2x, integral of cos is sine, but because of the 2x is a half sine 2x. So my integration by parts always tells me that the integral of u dv by dx is equal to uv minus the integral of v du by dx. So we're just substituting everything into that. uv is going to be those two. So uv is x squared over 2 sine 2x minus the integral of v du by dx. V du by dx is the bottom two, so it's 2, let's just do it slowly, it's 2x half sine 2x dx, but easier than that then is going to be x squared over 2 sine 2x. We can just tidy up that second part to minus the integral of x sine 2x dx. Now, as I said right at the very start, what we've done is by putting this process through once, we've at least got rid of the x squared, and now we've only got x sine 2x. But if we do the process a second time now then, so I'm just going to make it clear to the examiner, I'm now doing the integral of x sine 2x. I'm just doing that bit there, and then when we get our answer to that bit there, it will be this minus that bit there once we've got that far. But let's just concentrate on doing that and not making any mistakes. So following the process through again, u is going to be equal to x, so du by dx this time will be 1. That's going to be helpful. dv by dx is equal to sine 2x, so v, just like last time, shouldn't have any problems with integrating something like that. If you do, go back and take a little bit more time on your integration. That's just straightforward integrating sine 2x. So putting that again into my formula, I always quote my formula, it means that I learn it, it gets into my head nice and quickly. And if I've got this written down like this, I think I'm less likely to make mistakes now as I'm going through trying to substitute in, because I've got that learned by heart. So in this case then, the integral of that works out to be uv, so that's these two this time. It's going to be minus x over 2 cos 2x minus the integral of v du dx, this time it's just minus a half cos 2x dx. So let's finish off that bit. That will just work out to be minus x over 2 cos 2x, and then the integral of that becomes plus a quarter sine 2x, and then we need our constant of integration in at this stage. Here, if you wanted to, you could have taken both minuses out, which might have made it a little bit easier to integrate before you were doing it. As long as you're getting the right answer, it doesn't really matter how much we're doing as we're going through and doing that. So remember this part here then now, this is the solution to that bit there. So the actual final answer is that, and very, very importantly, minus all of that. So don't fall into any silly mistakes when we're doing this. So my final part is to write down the actual answer to the question. The original question was the integral of x squared cos 2x dx, and that's equal to that bit there, which is x squared over 2 sine 2x minus all of this bit. So minus x over 2 will make plus x over 2 cos 2x. This then becomes minus a quarter sine 2x. The constant, we don't worry about changing the constant, it's just the constant, isn't it, as we're going through. So that's the integral of that first part. Okay, let's go back and look at part B. And it says hence solve the differential equation. So we're going to be using this integral that we've just worked out to try and solve this equation here. It says giving your answer in the form that, it's a bit far beyond me at the moment, I'll come back and look at it every now and then, y to the power of something equals, but let's just see how far I can get with doing part B. So part B says we've got dy by dt is equal to, and if I multiply it out, I'm going to get t squared cos squared t over y squared. So what we're going to do is to separate the variables. Separate the variables means put all the y's onto that side and put anything with t's onto that side. So what I'm going to end up with by separating these variables is y squared dy is equal to t squared cos squared t dt. And then what I can do is the integral of this side is equal to the integral of that side. Right, well the integral of that side, that's no problem at all. Y cubed over 3, I can do that. It's this part here, so I immediately go back then and say, right, okay, what did I have previously? Well, I had x squared cos 2x, or t squared cos 2t, if we change the variable here, but I've got cos 2t, and in my integral here, I've only got cos squared t. So hopefully, that reminds you that what we've then got to do is to use one of our trig identities, and we've got that cos 2t is 2 cos squared minus 1. So what that means is I can rearrange to get cos squared equals, can't I? I'm just going to do it quickly because you should almost know this anyway. That means that cos squared t is going to be cos 2t plus 1, but then it's all divided by 2, so half cos 2t plus 1. So in this integral of y squared dy then, I'm going to get integral of y squared dy is equal to the integral of t squared half cos 2t plus 1. Well, let's multiply that all out and tidy that up. That's going to be the integral of y squared dy is equal to, if I take a half out and multiply out the brackets, I'm going to get t squared cos 2t plus t squared. So we should have dt on all of these things here. Okay, well, looking at that now, at least here then, I've got the integral of t squared cos 2t x squared cos 2x. So brilliant. I don't think I've made any mistakes here then in now trying to tidy this all up. I can integrate this part using my previous answer, and I can integrate this part just because I know how to integrate t squared. It's t squared over 2. So if we now integrate everything, we're going to get y cubed over 3 is equal to, ignore that, a half. So the integral of the first part will be t squared over 2 sine 2t plus t over 2 cos 2t minus a quarter sine 2t. So it's all of that, and then the integral of t squared becomes t cubed over 3, but with that half there, well, in fact, let's just leave it as t cubed over 3 to start off with. So it's that, plus a constant, stick a constant on at this stage, stick a constant on at this stage, and then what we need to do now is to tidy this all up. So if I multiply everything by 3, I'll get y cubed equals, multiply this all out, so this would be, I'm not going to, I'll just do the first bit. Half times that would give us t squared over 4, but then the 3 multiplied by everything is going to give me 3t squared over 4 sine 2t, and then just carry on doing that and say, you can do that, I'm not spending any time on the video saying all this. It comes to 3t over 4 cos 2t, it comes to minus 3 over 8 sine 2t, and then it comes to plus t cubed over 2. All plus the constant. We never worry about changing the constant when we're doing this. Right, quite a bit of complicated algebra in there, but you know, it's a P4 exam. We should be able to focus and cope with most of that. So hopefully that all makes sense to you.